Yeah, so welcome to the May beginners/newcomers workshop. I'm glad you could all make it. We've not run one since February, so I imagine there's been a few of you waiting for the next one. We are recording it for those who are unable to make it or can only make it some of it, and it will get uploaded to the Datashield YouTube channel by this afternoon, so you can either share that to any of your colleagues who'd like to know more about Datashield, or go back over any of the code that we went over too quickly. But we'll be stopping for questions throughout the code demo, and there'll be at least 20 minutes at the end of further questions. So my colleague Dimitri is here co-presenting with me, and Stuart Wheater will be joining about halfway through to help with the questions. So, moving on, can you see the structure slide now? Yeah. We've just been waiting for everyone to join, and now we've got a short, very brief introductory slides, and then the vast majority of the demo will be actually in our studio using our script. And then after we finish with that, I'll give you a survey monkey just to get some quick feedback on how you found the delivery of the session to help customize it for future sessions. And then we've got questions actually for half an hour, not 5 minutes. So that's a slight mistake there. So what is Datashield? So I've tried to write it in this slide as simply as possible to get the concept across. So Datashield is a tool for analyzing data that you can't access or view in the normal way. So this can be for a variety of reasons, such as patient confidentiality in a medical cohort study setting, or an intellectual property protection setting. In a commercial setting. Regardless, it's a restriction and you must work with it. So Datashield provides ready-made ways to do so. In Datashield, you request a result, and Datashield is set up to decide whether or not that result is too revealing of the low-level details. And if it is, you're locked from seeing the result or answer you were looking for. This is called the active disclosure protection, and it's very useful to give data owners and custodians confidence that their data is not going to be misused. Another feature of Datashield is its ability to remotely co-analyze data spread around the world. So the commands actually go out to the data in their databases that are hosted remotely. So this bit is known as federated analysis, and it's both efficient at distributing the computing load and statistically powerful by allowing you to increase the sample size, connecting to lots of sites around the world instead of just the data at your university. The statistical power of your results can increase from that. And so the data isn't put at risk by being transported digitally or physically to the researcher. So a small animation for that. Also, it avoids the challenge of transmitting large data quantities where the large data sets can sit in place and data like queries are sent back and forth instead. So I've got another animation on the next slide showing the federated analysis structure. So here's me sitting here in Newcastle upon Tyne in Northern England. That's the Datashield logo flashing. So say I was an analyst and I wanted to do some medical research, and I knew that the data was stored all around the world. So some data sets in America, around Europe, Eastern Europe. So I turn on my computer, turn on an R session, and that's my analysis session. And because I'm already working with those studies around the world, they will provide me with login details. so I can put them into a script and send them across, proving who I am and connecting with the data servers R session. And so that link between my analyst session and the data server session is the Datashield session. And so then I come up with some statistics I want to run on the data. Maybe it's finding some averages or some measures of spread. Put that into the specific Datashield syntax that we're going to be teaching you in the live code demo. And then I'll hit enter, and that will send it through the internet to the data servers session, where it will crunch the numbers and then decide whether or not it's actually eligible to be sent back. So it will check for any disclosure issues there at the server in place. And then assuming all is fine, then it can get sent back. Ooh. That animation went the wrong way, but anyway. And then, I've skipped backwards, sorry. There we go. There, the results go back. And simultaneously, this is happening to all the other servers that you connected to. So they all get the commands you sent and send their results back. And then they get combined into a meta-analysis, thus fulfilling the federated aspect of Datashield analyses. So, some key properties of Datashield are that it runs using the R language. The analyst sends commands from an R session using installed Datashield libraries, and then the servers which also run Datashield libraries receive the commands, conduct the analysis, check it's not disclosive, and send back the results. And lastly, it is open source, so this means that our code is freely available on the internet through GitHub for you to actually go and have a look, and even to download and modify if you want to do. So what we're doing today in the live demo, we have sourced some data on the Titanic passengers, and the repo for that was kaggle.com, which has lots of interesting data sets on there. And to simulate a federated Datashield analysis, we have chopped the CSV in half and put it in 2 locations on the Opal demo server that we're going to be connecting to. So this is simulating it being in 2 geographically distinct servers, like it was in different ticket offices that stored the data, but in reality, it's just on the training server. And these data sets do contain actual names and ages and that kind of confidential data that Datashield is very suitable for. So now it is time to actually go into our studio. Just while I'm changing over, Dimitri, are there any questions?
There are no in the chat. I don't know if anyone wants to ask anything.
Yes, I have a question. So based on this demo you showed, it's like you are assuming the data from different servers are completely independent. So what if I need to fit a model which will, it's like a linear mixed model in which I need, like say, a random effect from each of the centers? Is it possible to use Datashield, or you can only use the thing which will use a meta-analysis to combine the final data, the final result?
Basically, for fixed effects models in Datashield, we offer both options. So you can do the one-stage approach where you fit the regression model across all studies, and you get identical results with the case where you are able to pull the data in one central location and analyze the data as having only one center. And the second option is to do the two-stage approach where you feed the regression model in each cohort, in each study separately, and then you meta-analyze the regression estimates. But this is available only for fixed effects models. For mixed effects models, we have only the function to do two-stage approach. So you do the meta-analysis. And we are working to develop the pooled version for mixed effects models. It's under development.
Okay, thank you.
Can I also just ask a question as well? So for each of the sites who've got the original data, the data has got to be harmonized by them first of all before you can do the analysis. Is that correct?
Yes. Yes, this is a requirement, and usually harmonization, it takes a long time. And it's a big process before the use of Datashield. In the latest version of our packages, we offer some functions for data manipulations. So if something was missed through harmonization, the user is able to do some manipulation, for example, to create a new variable based on existing variables, or if you have a continuous variable, to categorize the continuous variable. You have the flexibility, but in consortia, they do the harmonization before the use of Datashield.
Okay, so each of the different consortium need to have access to Datashield as well, because they will run whatever program that needs to be run at their end, harmonizing the data. And if the code that's sent in, like you said, is working off of categorical data, but then the continuous data that they have on their end can be categorized, they need to first of all categorize it before the datasheet code will work. Is that correct?
Yes, but you have also the option as a user to do this type of transformations if you want.
From here, so from where I'm based, I can do it on their end as well for them.
Yeah, for example, one consortium, they might decide to, let's say, yeah, basically, let's say that they have income as a continuous variable. They don't do any transformations, they harmonize income. They harmonize it in a way, for example, if you have cohorts from Europe, they might based on a specific range for income. But if in your consortium you have cohorts from other continents, they might have a different range. So you have income, let's say in that case, as a continuous variable. But in your projects, and this is done during harmonization, they decide to keep this variable as continuous. But for your personal project, you might want to use income as a categorical variable. So you, as a user, you have this flexibility.
Okay.
Yeah.
And that would work as a user. I mean, so the code that goes out to the consortium would categorize it, or would it need to be categorized before Datashield is used in the harmonization stage? Is that?
You can do it using Datashield after harmonization also.
Okay, thank you.
Cool. Any more questions, or should I go to code? Okay, right. Screen sharing. So hopefully that code is large enough for you to see. If it's not, shout out now or put in the chat and I can zoom in a bit further. So what we're looking at is an R Markdown script. So some of you may have already seen these, but it's a bit of a better way of presenting code than just an R script, because you can have this markdown text here for actually talking about the code that's about to come up in these code blocks. So if you haven't got R Markdown already, this is the code that you'll be able to use to install it. And before I go any further, there is a link to go to on the website where you can download this code. I'll quickly put the link in chat in case anyone wants it. But certainly after the session, you can go there and download this and recreate what we did here today. So we have already shown you the concept of Datashield in the slides. So now we'll actually have to go through the setup process. So Datashield runs on a variety of packages, which you will have to install if you've never used it before. So there's three main ones. It are DSI, DS Opal and DS Base Client. DS Base Client is the one that contains all of the functions that actually send data to the data service and receive it back. DS Opal are some procedures for how you communicate with the server, and actually DSI is quite similar to that as well. So it's important to get the repos argument of this install packages for the DS-based client installation. So once you've installed them successfully, then you can load them into load them into your R session using this library command, as you do with any non-base function in R. So going on, we're going to use this server. So it's the Opal demo server run by our colleague Yannick in France. And he's recently updated the security protocols. So the password now requires alphanumeric and special characters. So if you're joining new to like a consortium that's running an up-to-date Opal, you'll now have to create these new passwords. So this login data frame is the main mechanism that you actually get into data on Datashield. So it looks quite big and daunting, but we can break it down. So first of all, you create the object. So we're going to call it builder for the building the data frame. And you assign to that this DSI command new login builder. So once you've got the object, you then append to it each server that you're connecting to. So in this case, I've got the first Titanic passengers data set and then the second one. So if I highlight this code, that's all of the code you need for the first append to connect to the first data set. And then just below it, very similar, but with slight syntax differences, well, slight argument differences rather, I should say, is the second data set. So the actual arguments, so the actual server name, this is what it's going to appear as in your analyses printouts in your console. So make sure that's named something very logical so you don't lose track. Like if you did study 1, study 2, study 3, you might start to forget what they actually stood for. So descriptive as possible. Then there will be a URL. So we are connecting to the URL of the training server, but your consortium might provide you a live data server. So you'd put the URL in there. And then your username. So we're just using the basic user profile on the training server. But again, you will probably be given a specific username password combination and likewise password. And then the table. So this syntax is according to how the Datashield, how the data is uploaded to the server that you're connecting to. So data is loaded into folders called projects. So this is the project on the training server. So Titanic Newcomers workshop, and then use this dot to separate the file from the directory. And this is the actual file name within the project. So Titanic server 1. And then in the second one, we've got Titanic server 2. And then we have named this dataset 2 so we don't lose track. And then these drivers, they always stay the same. So you can just save this login builder away somewhere that is easily accessible for you, and then quickly paste this in to whatever analysis you're doing, and then customize the specific arguments that you need for that analysis. And then at the end here, this builder $build stitches it all of the above together into a new object called login data. So I've left that free in case you want to build it yourself when you download the script. So this line here is the actual command that logs you in to a Datashield server. So if I run it, did I run? I might not have run this. I'll run this one first. There we go. Created the login data object, and then so this one, as it was running, I had it slightly too small, but you get this progress bar showing that you're successfully connecting to all of the servers. If there's something wrong, this will get stuck halfway along and it will tell you which server it didn't manage to connect to. So you can go and have a look at the login data frame and you'll probably find there's a mistake. But if not that, then you've debugged it, pardon me, to the point that you can contact the server administrator and ask them what's going on, maybe something wrong with the server. So if you make a mistake, like put the wrong password, for instance, here, I've purposefully done the wrong password, and run that. And then I've got the connection line here. So that error is client error 401 unauthorized. So what if I instead take the right password and try and connect to a server that doesn't exist. So I'll run that. So this is the one where it goes wrong. So the first one was fine because that was right. The second one goes wrong. Titanic dataset to no value table exists with a specified name. So the specified name being Titanic server 3. So yeah, you can get used to these printouts to learn what they're telling you about the error that's going on. It's not the clearest for beginners. Certainly when I began, it was a bit unclear, but you can look inside of this printout and find out what's going on. So if I go back to the top one and run that, then we should log in and be set up to go. Signed all tables, 100%, all good. So now that we're in, how to actually find out some information about the data you're analyzing. So obviously the whole point of Datashield is you can't directly look at the data. So we're going to have to deduce things about it by running some of the commands I'm about to show you. So start off with what are the dimensions of the data. So I'll just do ds.in. Oh, that's a good point. So you need to provide the actual name you've just connected to. So I'll do x equals g because I think I called it. Yes, sorry. So here, when I was doing the connection line, this symbol here is really important because every Datashield command you write, you need to specify what you are sending the analysis command to. So here we're sending the analysis command to the whole data set or sets that we've connected to. So, and then you've got the data sources argument here. Run that. So there we go. So what we've connected to are two data sets, one with 11 columns and 444 rows, the other one being the same 11 columns and 447 rows. And this shows you some combined data showing what the overall study would be. So say we didn't know how to use that ds.in because I'm just showing you. Well, you can access Datashield help functions in the normal R way by doing this question mark just before the function, or indeed by searching in the help, in the ds-space help. So if I actually run the help command here, then it loads the help documentation in this window. And it will give you the basic usage. It'll give you the input object, it'll specify which arguments what options there are for each argument. Quite a simple one, so not many arguments to specify here, but just the object you're connecting to and the data sources are the key ones to put in each time. So moving past that, so here we're going to run DSDIM firstly on all of the data sources, but then on just one of the data sources. So that's by taking the data sources list and then doing just the first object of that. So run that. So the first one is as we saw above. So we didn't specify the data sources connections object, and it just deduced that it was that. Then the second time we did, and it's the same thing. Then the third time we took only the first connection object, so that's connecting to the first study. And that is this one. And then fourthly, we did Datashield.tables on the connections object. And that's this. So this is all of the things uploaded to the server that you could have connected to, but we've only connected to the Titanic ones. So what else can you find out about the data? So column names will be quite important. That's certainly something you'd look straight at if you were looking at this CSV in a spreadsheet viewer. So ds.colnames, specifying the object. So D is what we call the object on the server. And then this is telling you which of the servers to connect to. So if I run that. So here are the names of the columns. So survives, that's going to be pretty obvious that it's whether a passenger survives or not. But things like P class or SIB SP, that's a bit less clear. So what we're going to need is a data dictionary to work out what all of these mean. And we do that by actually going to the Opal portal online. So I have this prepared. So here is the Opal portal online. So this is the Opal demo one. So if you were doing a live study, you would be given a different URL, but you will come to this online portal to log in. So it's DS user, here's my username, and the password, this would be some numbers. Sign in. So now we're on the dashboard. How we navigate this is we go to projects. And this is that list that we saw earlier in the printout, and we'll want to go down to the Titanic one. And then once we're in the dashboard of the project, we will want to go to the actual tables. And then these are the two servers that are simulated being geographically separate, but we'll click on one of them because they're both the same. And here we've got the data dictionary. We've got a summary of the data, very basic. But what we don't have is the data tables themselves. So a basic analyst in Datashield can only use the dictionary and use Datashield to deduce things about the data. They can't look at it outright. So what are some of these things we were confused about earlier? So SIB, SP, so that means the number of siblings or spouses that person had on board the Titanic. Other things it tells you is what value type it is. So whether it's decimal, text. I thought some of them were integers, but turns out it's not. And then this embark thing will be interesting later. So tells you which port this passenger got on board Titanic. And it's going to be printing out S, C, and Q coming back from the server. But what we use is the data dictionary here to work out that S means Southampton, C means Cherbourg, and Q means Queenstown. So we'll leave this open for later to come back to it. So back to our studio. This is just a bit of text that you can read if you download it later, but you obviously can't do the head of the CSV or the data frame to look at and find out the basic properties of each column. You do have to go this route into the data dictionary and data properties commands. That's just something you'll learn about using Datashield, and you'll get used to it. So what statistical functions, or what are all the functions we can do on the data in Datashield? So we've got this built-in function in DS-based client, it's called list client-side functions, and that is literally everything. So DS-based client functions, these are all of the analysis ones. So abs, bool, box plot, cbind. And if you actually wanted to find out what these do, what you can go to is this wiki article. So I'll go to that now. And this wiki article, it categorizes all of the functions available, and it's also searchable, and also it links through to the documentation page for that function. So if you wanted to know more about, for example, how to use the mean and average function, you can click on this and it goes through to the Datashield CRAN. It's basically the same as the help function that you were running earlier, but it's a bit more visual and it's a bit more sorted. So yeah. So what we're going to do now, scroll past all this. I'll minimize this, it's a bit big. So say we actually want to look at a specific column now. So we'll look at the age column. So just if you've used R before, then you're taking the data frame object and then looking at a specific column using the $sign, and then looking at the age column. So num NA, so that's going to be the number of missing values in that particular column. And because we're not specifying a number here, the connections is going to look at both of the servers connected to, both connection objects. So in the first server, we've got 87 missing values. In the second server, we've got 90 missing values. What can we do with this? Well, we can deduce the number of non-missing. So we take the overall length of the age column. So yeah, that was the same as the dimensions before. And then we will calculate the length minus the number of missings to get the number of non-missings and print them out. So as that happens, 357 in each. Complete cases, that might sound a bit similar, but in fact it's different. What it does is take the overall data frame and go through row by row and delete any row that has any missing values anywhere. So not just checking for missing values in age, but if there was one in SIB-SP, then that would be removed from the resulting table as well. So if we run that, a new object has been completed called d_complete.cases. It's checked to be valid. And then we'll go and confirm that this is actually a bit smaller. So what's happened there? Oh, I specifically made an error here. So oh, it's because I gave it the wrong. So its actual name is D_complete cases. So, right, okay. So here it is. This is how you would actually do it, because this is a new object that hasn't been created inside the data frame that we connected to. Because it was an assigned type function, it created it elsewhere on the server. So instead of doing $, and looking for a column in that data frame, we're just looking at this separate object that is called D_complete cases. So this one is actually only 87 rows long with 11 columns, and the second study resulting in 96 complete cases. And this is quite an important function to run if you are running a generalized linear model, which would require all of the different columns to be quite complete. So what I just demonstrated there was creating a new object on the server side, and that's called an assigned type function in Datashield. Whereas the types of functions that bring an answer straight back to you are called aggregate type functions. And that's quite a big distinction because assigned types are usually creating a new object that is disclosive, but you could then use for subsequent analysis. Whereas aggregate type functions bring you back something to the analyst's session that you can view and is guaranteed to be non-disclosive. So if we go on, we can have a look at some statistics that are going to be aggregate type functions as they bring it back to us and are non-disclosive. So if you want to present some discrete variables, so we can use a table function for that. So the help function for a DS table. So you've got the row variables, the column variables, and that would be the stvar means it would create a 3D table. You've got the option for chi-square tests. You've got the option for whether to discount any missing values, and then a few more niche arguments. So we can have a look at the embarked column and check if that's a discrete data class that could be fed into the Datashield tables. And the result is it's a factor type object. So that's good because a contingency table requires factor objects to be put into it. So we'll run a table, just a one-dimensional table on the row variable embarked. And we'll only look at the first server for this. So that's using this data sources equals connections one. So now you get a validity check, an error check, and then this is a printout. So this table is not telling you very much, so I'll skip past this for now. But this one is telling you that 72% of the passengers stored in table 1 boarded at Southampton, and then 18% in Cherbourg and 10% in Queenstown, Ireland. So that's the proportions table. Then you've got the counts table. So that is showing you 319 passengers who were stored on server 1 boarded at Southampton, and 81 for Cherbourg, 43 for Queenstown, and only 1 missing value. And then it presents you in the alternative arrangement, so like crossways instead of lengthways, which will be more important later when we do a two-dimensional table. And then finally another validity check message. So what would happen if we change this to be both the connection objects? So I'll delete the one, and it now it defaults to both at once. So now we can see that so this is the study one as before, 72% boarding at Southampton. But on the other server, 73% boarded at Southampton, 19% at Cherbourg, and only 8% at Queenstown. So you can see it's slightly different data stored on each server. And then you've got the counts as before, and then portrayed in the horizontal table. So not only can you do the one-dimensional tables, you can also do the two-dimensional ones. So you can maybe check the survived category against the passenger class category. So we'll run that. And this is where it gets interesting. So you have to, first of all, look which way it sums up to 1. So here you can see of those that did not survive, so 0 for survived, 15% were first class, 19% second class, and 66% third class. And of those who did survive, 33% were first class, 26% second class, and 41% third class. So yeah, it's just important to read these tables the right way. So always check which way it sums to 1, whether it's horizontal as here or vertical as here. And then after the proportions, you've got the actual raw counts. So this is, so I'll go through the actual structure of the printouts. So you've got the validity checks and error checks, and then you've got the proportions. Oh, it's changing it. So validity checks, error checks. Then data, the first server's row proportions, the first server's column proportions, the second server's row proportions, the second server's column proportions, and then the combined proportions in by row, by column. And then after all of the proportions are printed out, then you get the counts print out. So splits firstly into the first server, then the second server, and finally the combined servers. So that's how to read that. And then another cool feature of the Datashield table is it's got a built-in chi-square tests argument. So if you run that, then after all of those proportion and count tables, as I showed you earlier, you've also got the chi-square statistic and the degrees of freedom that is calculated for the tables that are printed out, and the p-value resulting from that. So yeah, we'll minimize that result. So moving on to some continuous data. So remind ourselves of the column names. So okay, so we've got like name, sex, age, fair. So if we want to know more about the age, we can find out what the mean age is and the variance of the age. So you can see it's pretty similar across server 1 and server 2. Also usefully reporting the number of missing values. And then the variance is, the second server is interestingly quite a bit higher than the first server. I'm not sure what that means other than just a quirk of the data. And then this function here will not only calculate mean, but it will calculate some of the quantiles as well. So if you wanted the median, you want the 50th percentile, which is here, but you've also got the 21st quantile, 3rd quantile, 90% mark, 95% mark, etc., as well as the mean, as I said. So this is doing both the pooled data quantiles and split by data sets or studies service. What else can we do? We can present those measures of central tendency and spread visually, such as by a histogram. So running the question mark will get us the help documentation, and then we can actually build a histogram using the inbuilt histogram function. So a key thing here is that non-disclosivity is preserved by hiding the bins at the end, so that you can't see like one outlier up at 90 to 95, which could give away the age of an outlying passenger. So only the bins in the center where there's a certain number of passengers pooled together are allowed to be plotted. So if we hide that one, we can also scatter plot the data. So if we scatter plot age against the fare that they paid, we'll just run this one. So here's two plots. So I think that's going to be the first server's plot and the second server's plot. Obviously not too much going on here. And again, this isn't giving away the private passengers' data because these points aren't the actual representations of the passengers on the server. There's an algorithm which is randomized the plotted point, which Dimitri developed and can tell you more about if you're interested in. Then moving on to the end of the live demo, I'm just going to show you a way to save any work that you might have done in a Datashield analysis session to be able to come back to it later without losing all of your work or having to spend the time of rerunning all of the created objects or all of the code you just worked on. So, for example, an assign type function like dsAssign creates a new object on the server and stores it while you're logged in. But if you just logged out, you could lose all of that. So I'm going to create now example object A here. And it's just going to be a vector from 0 to 5. And then we'll list the objects on the server using ds.ls. So we have A, which we just created. We've got D, which is the overall data frame that we logged into. And then we've got the D complete cases that we calculated earlier. That's confirmed to be both on server 1 and server 2. So after that, you can do a workspace save using the DSI package. So what I'm going to do is call the workspace 2022 May Alex Westerberg, so my name. So it's not going to be overwritten by anyone else because no one else is likely to use the same name as that. So that the next time that I log in, so firstly I log out and then log back in. But I'm going to log back in using this restore argument here, using the same name as I saved just before. So I'll run that. And then I'll run the list of objects on the server. And even though we logged out, we've logged back in and restored the session where all 3 objects are here ready to keep going where we left off. So there we go. Finally, just log out. So I can see there's lots of questions. So I'll start the share and we can start answering them.
Hi, Alex. I was trying to respond, but I want to just say we have a question on if we can do a table for all the categorical variables that we have in a data set to include the length or the length of non-missings and the percentage, probably the percentage for each category. My first answer was no, because I was thinking about the DS-based functions, but actually Tim Padman, that is working for the Lifecycle project, he developed a package which is called DS Helper. And DS Helper, it's a client-side only package. So the servers, they don't have to install anything, but you can use this package on your analysis computer. And this package includes functions which can help the user basically. And one of the functions, if I am right, is called, all the DS helper functions, they start from DH instead of DS, DH dot. And if I am right, this specific function is called DH dot get stats. And you can have as input and data frame. And what is returned is some summary statistics of categorical variables and also summary statistics of continuous variables. So it's good if you can have a look on DS Helper. I will try to find the link of the code from GitHub and put it on the chat here. But Alex now is presenting the DS-based client, which is our main package in Datashield.
Possibly should have made that clear at the beginning, because as time's gone on, more and more packages have been built to complement and enhance the DS base, which is the core methods of Datashield. So, question. Yes. So, yeah. Any other questions other than Courtney's? Cool. Thank you, Mario. So as I said earlier, you can go to the website. I put the link above, I'll put it down again, where you can download the code that I just presented and actually run it for yourself. I think there's multiple DS users allowed onto the Opal training server at once. And just make sure that when you create objects, that you create a unique name for them, so you're not overwriting each other's objects. Oh yeah, if I could ask you to do a quick survey, that would be really helpful to just see how this session has gone. I'll share screen. Slides. So there's a QR code, and I'll put this link in chat.
Yeah, there is another question on the chat. If we can obtain the residual sum squared from a linear model. Actually, the difference between R and Datashield functions, in some cases, how we develop Datashield functions, we just wrap Datashield functions on the server side. In many cases, are wrapper functions of existing R functions. One difference is that we restrict what we return as an outcome to the user. So for the regression functions, we don't return the fitted values and the residual, because then you can get the difference and estimate the actual outcome variable. But what you can do, you can, and depending on the method, the two approaches that I told you before, either the one stage or the meta-analysis, there is a way to calculate the fitted values and the residuals and on the server side and save those as vectors on the server side. And when you have these vectors, you can square the residuals. And for the sums, you can extract the sum, because we have a function which is called row calc. So you can do calculations for a row or for a column, and you can get back the sum of square residuals, or the sum of the difference of the residuals, the sum of absolute value. Depends on what you want to do, but there is a way to do it. Yes. And also having before you get the sum, having the vector of residuals on the server side, you can do other things like, for example, you can do regression plot diagnostics to plot residual versus fitted values. And what you get back in your console as a plot is what Alex showed with the scatter plots. You get a scatter plot between the two, but are not the actual, the coordinates of each point that you see in the scatter plot is not the actual values that you have on the server, but we somehow anonymize this data before we create the plots. Okay, but the anonymization process is happening only for the graphics. All the analytical functions are applied on the real data, on the actual data.
Are there any other questions?
Yeah, I have a question about those plot Dimitri was talking about. So the anonymization algorithm used doesn't distort the pattern I would be looking for. Let's say if I'm trying to check the linear model I fitted on my data, if it was okay, it doesn't violate the, let's say, the constant variance. So your anonymization algorithm doesn't distort the relationship I would observe if I had the real data.
Yeah. Basically, we have developed two approaches for anonymization. One is about probabilistic anonymization. We add a small, for example, if you want to create a scatter plot, you have 2 dimensions, and through probabilistic anonymization, we add noise in both X and Y variables, but we add the noise in a way that the statistical properties remain stable, so you don't lose any information. However, the user is able to define the level of noise that you want to add, but we have some thresholds. For example, the level of noise in probabilistic anonymization is defined as a proportion of the initial variance of the variables. And if, for example, if you say this level of noise equal to 0, I don't remember how we define the parameter, but if you say 0, for example, then you get actually the same data without noise. But in order to restrict this, we have a minimum value for the level of noise that you can add. But then it's up to the user on how much above this threshold noise can add. But we make sure that the statistical properties remain the same. So for example, if you have a correlation between the 2 variables or a specific relationship, these remain the same. And the second approach, which is better than the probabilistic, we call it deterministic because in that case it doesn't depend on random numbers. For each data point, imagine that you have a two-dimensional space. For each data point, we look for the k-nearest neighbors, and having the k-nearest neighbors, we calculate the centroid and then replace the point of interest with this centroid. And we do it for all the points that we have in the plot. And we did different sensitivity analysis for that. As a user, you cannot see if the plot that you get, how close enough is the plot that you get with the plot that you can do with the original data. But actually, I will share with you a paper that we published where we explain these techniques. And you can see there on, if you vary these parameters in the different techniques, how the plots changing. Okay, let me put it here. And now this paper that I put the link here, we describe the statistical techniques to anonymize the data before the plots. And at the moment we are working on a follow-up paper to show how the graphical functions in Datashield are using the same techniques from this paper to produce the graphics in Datashield. But if you have a look on this one, is the same methods.
Okay, let's say you have those visual plots in which you are trying to check if, let's say, some point where like inferential outliers, for example, if I need the Cook's distance or average. So when you generate those plots, you still add those randomness, and they keep like the wherever I should obtain, for example, if I'm interested maybe to make sure that the model is or the point I'm not, let's say I don't have any influential outlier.
Yes. At the moment, actually, we are working, we don't have a function to produce regression plot diagnostic, including Cook's distance or QQ plots or this kind of stuff. We are working to develop a function through the Athlete project about this, but we are going to use the same techniques. But the difficulty with that, even if you see that you have an influential point, at the moment you cannot do anything. You can, I'm not sure you can do a subset of the data excluding the row with the influential point. But also you have restrictions on if you do if you have only one influential point, you have restrictions on subsetting because we are not allowing subsetting of less than 3, for example, rows. So what I want to say, there are some restrictions in relation to the disclosure controls that we have in the functions.
Okay, thank you.
So just I may have missed it. Sorry, Dimitris and Alex, but to use this, it's free. So what is the next step? So if we want to if we have a project we want to use this Datashield for, what do we do to access it? Is it, yeah, sorry if I missed it already.
What do you mean, what to do next? For example,
so if we've got a project I want to run using Datashield, are there software that needs to be downloaded to all the consortium partners? If it's free and it's open access, so do we just access some sort of I don't know. Yeah, sorry, I'm just trying to understand how do we
how to set up.
Yeah, set up and all of that. Yeah.
Basically, if you a consortium, each study that is involved in a consortium, they have to upload their harmonized data in a server that they have in their location. In that server, they have to install R, and some server-side Datashield packages, for example, DSBase, and some are dependencies if are needed, depending on what analysis for example, DSBase includes the base function, but we have, for example, a package which is called DS Survival. If the consortium that you are involved, they are interested to do survival analysis, they have to install also the DS Survival. But and we have a number of packages other than the DSBase. Now on the analysis computer where the user sits, there are two types of settings. In some consortia, they have a central analysis server, like the Lifecycle Consortium. They have a central analysis server where on that server, they have installed the client-side packages. So each server has DSBase. The client-side has the DSBase client, which is the pair, the pair of DSBase. You need to have both and the same version. The second setting, if your consortium doesn't have a central analysis server, you can access each server through your RStudio in your local machine. But if you are a member of a consortium, each study that they hold the data, they need to give you some credentials, which are user specific. So you need to have, you need to get permission from a study to access their data through Datashield. And then you have your personal credentials. And for each study, you have different credentials. And then you access these data through the initial part of the script that Alex showed. In the script, we are using username, user, and password. But in a real setting, you will have a specific username and password for each study separately. And then each study that gives you access to their data, they should give you also the name of the table or more than one tables that they have. They include the data that you are requested to have access, because in big consortia they might have hundreds of variables.
Yeah.
A user might ask for access in few of them. Okay. So they give you a small subset of the big data set, and you have access to this table. Yeah, this is how the are you working for a specific consortium or not?
So it's the work I'm involved in is IPD meta-analysis. So either using randomized control trials or cohorts. And a lot of the obstacles we face is where you've got the collaborator who's keen on sharing the data, but maybe there's some issue, or it's just taking too long to get the data access request signed off and everything. So if we're going to get them to harmonize the data, then we'll also need to have them run the analysis using Datashield, I guess. So these people might not necessarily have secure servers or hosting sites, but they would have the data on their machines that they can access. So I just wanted to understand. So they'll need to have access to R and be able to at least set up the process to do this analysis remotely. So if they go out on their local computers and we send them the package that's needed to run, then we can access this data remotely, run the analysis, and then get the results, which we can then combine in our meta-analysis going forward.
Yes.
Okay. Yeah. So this yeah.
I don't know if you are going to add anything about Opal, because I didn't mention Opal.
Certainly, we've got to. There are parts of the community who provide hosting for it. So if you wanted to actually make a contract with them, they could host the server for you. Okay. Also, if you have access to some machine and that is externally visible, then that would be potentially a place to host the service.
Okay. Right. Thank you. I'm also going to say hi. Thank you very much. This has been very helpful, very useful. And if you've got any questions when we're using Datashield, can we come back to you guys to like?
Of course, yes.
Yeah, great, excellent.
Yeah. I don't know if Alex has mentioned it, but we do actually have a drop-in session on Tuesday mornings for just, for any problems at all.
Sure, right.
Yeah, from anybody in the community.
Excellent.
We have also a forum if you want.
Yes, sorry, yes, you're quite right. Yes, the forum is a good place because there's lots of pre-existing questions.
Excellent. Okay.
Yeah.
Okay, great. Thanks a lot. Thank you.
Thank
Nice
you.
to meet you guys. Bye.
Yeah.
All right, Gina, is that working now?
I'm trying to find the package.
If it's still not working, I've got a meeting from 1 till 3, but we could meet up and have a look at it together after 3 p.m. if you want.
Yes, thank you very much. Yes.
Cool. I'll come through and have a check then. Yeah.
Yeah, thank you very much.
Any other questions? Otherwise, we'll wrap up there. I'll take that as a no. Yeah, thanks for coming. And this will be on YouTube at the end of the afternoon. So you can pass it on to others or review the content covered here today. Yeah, thank you.
Thank you very much.
Thank you.
Bye.
Thanks, all of you.
Thank you. Bye.
Bye.